CNN are trained using backpropagation, where the error between the predicted output and actual output is propagated backward through the layers of the network, and the weights of the connections between nodes are adjusted to minimize the error. CNNs have been successful in various applications, such as image and speech recognition, object detection, and autonomous vehicles. They have enabled the development of systems that can recognize and classify complex patterns in images and videos, with high accuracy and speed. Recurrent neural networks, RNNs, are a type of neural network commonly used in deep learning for sequential data, such as time series data or natural language text. RNN are designed to process data with temporal dependencies, where the output at one time step depends on the output of previous time steps. RNN are composed of multiple layers, with each layer processing one time step of the input data. The output of each layer is passed as input to the next layer, creating a feedback loop that allows the network to learn from previous time steps. The basic unit of an RNN is a cell, which contains a hidden state that is updated at each time step based on the input and previous hidden state. The output of the cell is passed to the next time step as input, and the hidden state is used to capture the temporal dependencies of the input data. RNN are trained using backpropagation through time, where the error between the predicted output and actual output is propagated backward through the layers of the network, and the weights of the connections between nodes are adjusted to minimize the error. RNN have been successful in various applications, such as speech recognition, natural language processing, and time series analysis. One of the most prominent applications of deep learning is image and speech recognition. Deep learning algorithms, such as convolutional neural networks, CNN, have achieved state-of-the-art performance on image recognition tasks, such as object detection and image classification. Deep learning algorithms, such as long short-term memory, LSTM, networks, have been successful in various NLP tasks, such as sentiment analysis, text classification, and named entity recognition. Deep learning has also enabled the development of autonomous vehicles, which can perceive and respond to their environment without human intervention. Deep learning algorithms, such as CNNs and RNNs, are used for tasks such as object detection, lane detection, and trajectory planning. In addition, deep learning has been used in various fields, such as healthcare, finance, and cybersecurity. For example, deep learning algorithms have been used to diagnose diseases from medical images, predict stock prices, and detect fraudulent transactions. Natural language processing, NLP, is a subfield of artificial intelligence that focuses on enabling computers to understand, interpret, and generate human language.